Hello everyone, welcome back to my channel. So in today's tutorial, I am going to discuss about a new topic that is operational amplifier. OPAM stands for operational amplifier. The first part, operation, stands as different types of operation like addition, subtraction, integration, differentiation can be performed. And the second part stands as it amplifies an input signal like an amplifier. So it is called operational amplifier or op-amp. The definition of operational amplifier is an operational amplifier is an integrated circuit that amplifies the difference between two input voltage and produces a single output. The op-amp has two input terminal and one output terminal. The op-amp requires DC power so that the transistors are biased in the active region. Most op-amps are biased with both positive and negative voltage supply. The positive voltage is indicated by V plus and the negative voltage by V minus. So these two are the figure of op-amp. Now ideal parameter. Ideally, the input resistance Ri between terminal 1 and 2 is infinite, which means that the input current at each terminal is 0. The output resistance Ro is 0. The terminal 1 is the inverting input terminal designated by minus, and the terminal 2 is the non-inverting input terminal and designated by plus. Now, if we keep the non-inverting terminal grounded and provide a DC supply at the inverting terminal, then we will get an amplified signal, that is V out equals minus AOD open loop differential voltage gain multiplies V1. As V1 is negative, so the output is out of phase of the input. That means there is a 180-degree phase difference. Now, if we apply a voltage at the non-inverting terminal and keep the inverting terminal grounded, then the output will be V out equals AOD multiplies V in. As the input voltage is positive, so the output will be in phase to the input. Open loop differential voltage gain. As there is no feedback from the output to the input terminal, the voltage gain AOD is called the open loop differential voltage gain. Now closed loop differential voltage gain. There will be a feedback from the output to the input for closed loop voltage gain. Since the ideal op-amp responds only to the difference between the two input signals V1 and V2, the ideal op-amp maintains a zero output signal for V1 equals V2. When V1 equals V2, that means it is not equal to 0. There is what it is called common mode input signal. For the ideal op-amp, the common mode input signal is 0. This characteristic is referred as common mode rejection. We will discuss briefly about it later. Now, practical specification. Let the gain AOD, that is open loop differential voltage gain, equals 10 to the power 5. Now, if we apply V input equals 1 millivolt, then the output V out equals V 100 volt. But if we keep increasing the input voltage and make V1 equals 1, then the output will be 10 to the power 5. That means it is huge. So it is not possible because the output voltage cannot be larger than the biased voltage. So the voltage will be saturated and it will not increase. So here we can see that it is the V2 minus V1. That means the difference at the input terminal versus V output voltage curve. So if we keep increasing the difference between the V2 minus V1 at the input terminal, then the output voltage is increasing. But After a certain amount, it is not increasing and the voltage is becoming saturated. So this is the transfer characteristics curve of an op-amp. Now we have known about the closed loop voltage gain. So if the connection from the output goes to the inverting terminal, then we call it negative feedback. But if the connection goes to the non-inverting or positive terminal, then it is called positive feedback. It is used to produce oscillator. But the ideal op-amp characteristics resulting from the negative feedback analysis are the internal differential gain AOD is considered to be infinite. The differential input voltage V2 minus V1 is assumed to be 0. If AOD is very large and if the output voltage is V0 is finite, then the two input voltage must be nearly equal. The effective input resistance to the op-amp is assumed to be infinite, so the two input currents I1 and I2 are essentially zero. The output resistance RO is assumed to be zero in the ideal case, so the output voltage is connected directly to the dependent voltage source and the output voltage is independent of any load connected to the output. We use these ideal characteristics in the analysis and design. So thank you so much for watching my video. If you like my video, then please press the like button and subscribe my channel. Thank you very much.